Yeah.
Yep. Good. We're getting somewhere then. Right. So you can kind of probably blame Sean for this presentation, because the last time we did one of these kind of little meeting Zoomy things, he gave a presentation all about leveraging the power of SQL with web services or something. Now, this has got nothing to do with SQL and nothing to do with web services, but the point is, during that particular presentation, he made a point of saying how whatever you're doing, it's always good to kind of have created yourself kind of a series of sort of helper classes and, you know, helper functions rather than kind of relying on the out-of-the-box stuff. And so that's kind of really what this is kind of about, really. It's not exactly sort of technically sort of, you know, pulling up any trees or anything, but it was just a kind of little sort of class that we'd written, which when we were looking for things to talk about, we thought, yeah, it might be quite a nice thing just to show, because it shouldn't take long. So it's all about file handling, really. Why can't I? There you go. Because we've got an application that has to process a lot of files, a lot of text files, a lot of CSV files in particular. Our product itself doesn't have an API. I'm not making eye contact with anybody because I'll just get disapproving looks, I know. So it doesn't have an API yet. We do integrate with other people's APIs. We're still very much at the moment all about importing and exporting data with sort of text files, CSV files, and what have you. And often it's a question of doing both. Often it's a question of we export data from the application, the clients will open it in their favorite tool, Excel. What could go wrong? They'll make their various sort of changes and things and updates, and then they'll re-import that back into the system. So typically it's things like names and addresses, but it's not exclusively so. There can be sort of memo text, comments, you know, anything that's in the database, really. They can export it, they can break it, they can import it again. But we also do a lot of things like data transformations as well. We've got a tool which is designed specifically for kind of slicing and dicing data, because obviously we've got our imports where the file has to be in a certain format, and a lot of our clients will get data from various different places, whether it's the bank or, you know, or what have you, and it's never in the right format. So we've sort of got tools where they can sort of map what they're given into sort of, you know, the format it needs to be. They can kind of save that mapping. So every time they get a file in that format again, they can just kind of replay the mapping and it'll chop it all up and put it in the right format. Point is, it's a lot of direct input, a lot of direct output stuff. So that's kind of where we are with our application currently. And of course now, or very soon, nearly, we're going to have DataFlex 20, which means Unicode. Yay, smiley face. What could possibly go wrong? Which means, obviously, that when we're sort of doing our, you know, direct output and such, we could sort of start doing, you know, funky stuff like this, you know, if we wanted to. Just outputting a channel as normal here, creating myself a little CSV file, got 6 columns, but now I could sort of whack some, you know, Korean in there, this little sort of shrugging character in the 6th column there. Now, obviously, we wouldn't be hard coding daft sort of things like this, but you could imagine if this was reading from a database table and outputting, you know, names and addresses and comments and memo text, there could be all sorts of things, you know, smiley faces and what have you in the memo. So all of this data could come out now. So, you know, great, you know, we could sort of, you know, go ahead and what could possibly go wrong? I mean, this will be fine, right? Well, let's give it a go. Here I am in DataFlex 20, and here's just this little simple process that I'm going to run. It's what we were looking at before. It's just going to create a little file in the data folder. It's going to output 6 columns. It's going to output this text with these Korean characters and this little sort of shrugging character at the end, and then it'll just open the file and we'll see what it'll give us. So if I run this, so what have we got? Is this going to open? It's going to play. Oh, well, it kind of worked, except it kind of didn't. It's given us some rubbish. So I won't bother saving that. Let's go back here. Not so much Unicode as Unicode. Oh dear, sad face. Now it's all gone wrong. And that's simply because we just sort of threw data into this file as we normally would, but there was nothing actually in that file to tell the application that was reading it, in this case Excel, what that data was about, specifically that it was UTF-8. Unicode and, you know, and the particular encoding that was used. Now, some readers are going to be smart enough to work it out for itself. I think if I was to open this in Notepad++, it would probably show fine. But our clients don't use Notepad++. They insist on using Excel. So they would open this file and got rubbish. But it may have been that there was like 2,000 lines in this file, and it may have been the 1,900th that had got some data in it that was rubbish. They hadn't spotted it. They make a change. They just click save. They import it back in, and all of a sudden the data's gone screwy, and they're saying, oh, I thought your program could handle Unicode and blah, blah, blah. So the question is, how are we going to kind of like tackle this in our application? And the answer was basically what we needed was to stick a BOM or a byte order mark in this, which I'm sure everybody knows, but just in case you don't, it's just literally a sequence of bytes that goes in the file that tells the application reading it something about the data that's in there, specifically Unicode and what is the particular encoding. Because if we add a BOM to our file, then hopefully that same file, we could open it in Excel and it hopefully should be able to kind of intelligently work it out. So if we go back to my same example, exactly the same code, except there's now an extra sort of 4 lines in the middle there where I'm going to add a sort of little 3-byte string at the start of this file, which is the particular series of bytes that will tell it that it's dealing with UTF-8. There's these slides will probably be available, I'm sure, and there's a link there to a Wikipedia site where you can get all of the kind of BOM definitions, but equally it's dead easy to just literally Google and you'll find all of these. So yeah, hopefully if we give this a go, so if I go and this time do that, get rid of that. No, let's not do that. Let's do that. So it's exactly the same as before, except all we're now doing is doing that bit in the middle, just adding some 3 bytes, sticking a little UTR array, bugging it out to the file, and then it's exactly the same data. So hopefully if I compile that up and run it and open this file, yay, success. So this time around, the file is able to kind of work out what it was dealing with. And the crucial thing as well is that if I was to do kind of file save as, previously around it would have just said, oh, just as a CSV file. This specifically now would say UTF-8 encoded CSV file. So if our users sort of made changes and just click save, it's not going to be corrupting the data. It's going to be saving correctly, which is obviously what we want. So that's fine. That just means I've got to go all through my application and find all of those places where I'm doing direct outputs and add this kind of magical sort of BOM marker, and then hopefully we're back to a smiley face and everything should be fine. Except that kind of means code changes, doesn't it? And we'd got about 50 or so files, I think, in our application where we were doing either a direct output or a direct input. Because the point was we had to kind of address both of these. We had to address the direct output to make sure that we were adding the BOM marker to tell the client application that was reading it that we were outputting UTF-8. It's just the future of doing presentations, isn't it? I don't know why we don't do this more often. Have a beer when you're doing a presentation. But also, we had to go and visit all the direct inputs, because when you do a direct input, that'll actually read in the BOM as well. There's a forum post actually by Oliver Nelson recently, this is a little hyperlink to. He was bemoaning, I think, the fact that the direct input was grabbing the BOM, because he was saying, well, this is metadata and it shouldn't be reading in the metadata. Now, there's arguments whether it should or it shouldn't, but either way, we do need some ability potentially to kind of, get the BOM and see what we're dealing with. But at the moment, if you just do a direct input, it would read in the BOM. So if we were going to be adding it, we also needed to kind of, get rid of it. Otherwise, we might be sort of, breaking stuff. So basically, we had to go around all of our code and start sort of adding these various lines and things. But obviously, if you're like me, if once you suddenly start finding you sort of adding the same sort of 5 or 6 lines in all these different places, you think, hang on, this isn't the right way to do it. What I need to do is kind of standardize this. So rather than just kind of rely on direct output and then the same code, let's actually create a proper little kind of what we call a sort of file handler class that's going to take care of all of this for us. And not just for the BOMs, although obviously that's a big part of it, making sure we're adding them and then making sure that we're kind of stripping them out when we're reading stuff in. But also some of the other kind of admin that comes with this, such as taking care of opening and releasing the channels, because I'm pretty sure that we've all been there. Well, maybe we haven't, but I certainly have. When you write code and you go and get a sequential sort of channel and you do an input and output and you do all your processing and you close the output at the end, and then you forget that one little line that says release the channel. And of course you test it and it's all fine and it works, and then you sort of ship it and it works for the client until one day they run it about 8 times in a row or whatever it is, and then they suddenly start getting error messages because there aren't any channels left because you won't release them at the end. Such fun. Yeah, I'm sure you've never done that. But so yeah, taking care of making sure all the channels open release, and also other stuff that comes with it. Because we're potentially outputting memos which have got all sorts of crap in them. Lots of carriage returns, lots of embedded quotes, which when you're reading the things in a game can make it tricky. If sometimes you suddenly think you're on a different line and you shouldn't be, and what have you. So ultimately making the process of processing these text files a lot easier.
We need to check we're talking to the right person, and to reassure you this is a genuine call from Barclays, we won't ask you.
That's not me, I can hear. Anyway, so when we started to have a look at this and sort of think, well, how should this look? We kind of already had a model in front of us anyway, because really, if you think about a CSV file, it's kind of like a database table, right? It's rows and columns. And in fact, even if you just got a text file, conceptually, you can think of it as one row and one column. So if you think about how you'd potentially work with a database table, you'd have code potentially similar to what we're looking at on the screen here, where you'd start off by saying, well, what is the table that I'm kind of doing the find on? And then you'd go and pull the first record of that file into memory. And whilst you've got a record in memory, you could go and get the column values that you're interested in, which may be all of them, maybe some of them, do what you want to do with it. And then go on to the next record and just keep looping through until such time as there basically aren't any records left. And that seemed like a reasonable model to work with. So when we kind of started creating this little handler class, we basically kind of came up with an interface that looked a little bit like this. We'd create an object of our class, and just like with the table, we'd start up saying, well, what is the file that I'm kind of going to be doing finding the records of? So we'd be setting the file name. And then just like working with tables, we'd say, we'll go and read the first line of that file into memory. And whilst we've got it in memory, we can either go and get the row as a whole, if we want to return the whole row, or we could go and get a particular column value, or whatever, and then do what we need to do. And then once we've done what we need to do, just go on to the next line and just keep looping until such time as it says, well, I haven't got any more rows left for you. Found returns false, and then we just basically destroy it at the end and throw everything away. So I'm not getting channels, I'm not releasing channels, I'm not coding direct output, input, or anything. It's just all sort of taken care of for me with this kind of little class. So, I mean, like I say, it's not exactly groundbreaking stuff, but let's go and have a little sort of play and just have a little look. So if I, oh, hello, you're all in the way here. I need to move you all. How do I do that? You're all in there. Right, so let's have a look at this one. Now, it's a bit sort of verbose, this particular example, but it's to sort of labor the point, really. So I'm going to start off by sort of creating a little sort of file. And so all we do is we create a little instance of our little sort of file handler class, and I give it a file name. In this instance, I'm just going to call it CDS sequential file handler CSV. It's going to be my data path. And I want a header row, so I'm going to set a property that just gives it my header row so that it automatically outputs that when I start churning out sort of columns. And if I wanted to do this very simply, I could actually do what I'm doing for my third line. I'm actually outputting 3 lines here, and I probably should have put this as the first one. But if you want, you can just go say, okay, just write out this as a line, and you can put it all in one go. But if you want to do it value by value wise, sort of column by column wise, that's what I'm doing for the first 2 rows. So I'm basically saying, okay, so I want the first row value to be the word this, then is a test, and so on. So we've got 6 columns, 6 values, set them, and just to simply say, okay, go and write that out. So again, a little bit like conceptually, if you were kind of creating a record in a database, you'd be moving the values to the columns, then you go and say save record. So it's sort of very similar to that. And then for the second row, we're going to do the same, but this time we're going to just try and make it a little bit more funky, see if we can confuse it. We're going to start throwing in some embedded quotes and some sort of, carriage returns and things, just to see when we read it in, if it's clever enough to be able to cope with it, or whether it's going to get confused. But I mean, it's there really is nothing more to say about it. We create an instance, we set the file name, give it a header row, say, right, that's the first row, write it out. That's the second row, write it out. That's the third row, write it out. And then when we've had enough, we say, okay, destroy. And so if I compile this up and run it and have a look at it, then, well, yeah, as you'd expect, it's created everything that we want to. You can see the fact that there's embedded couch returns, which is why it's sort of gone on to sort of second rows and what have you. But yeah, I mean, it's not exactly technically brilliant stuff here. And then in terms of how we might read that in, go on to my third example. Now there's actually kind of 5 examples in one here, which is why it looks quite a lot of code. Actually, within each example, the code is very small. There really is kind of nothing to it. So same again, I want to read something in, so I create an instance in my file handler class and I set the file name. And I basically go and say, right, go and fetch the first row into memory. And as long as you got one, in this particular example, the first one, I'm actually going to say, well, how many columns am I dealing with? And then I'm going to loop through all of the columns and get each one value at a time and just load them up into an array and then just keep sort of doing that one at a time. So if we run that, we should be able to sort of see, you can see at the bottom here, if I, because we've got 6 columns, and then as we start to read them in one at a time, you can see this building up. So if I just sort of let that with, so that was my first row with my column headings, that was my second row with the kind of funky character in the Korean code. That was my third row where I was trying to fool it. Now by default it's stripping out the character returns, but it was smart enough to know, you know, it didn't get fooled into thinking that it was dealing with sort of more rows, or the row was shorter than it really was. And then my third row was just that single thing. Different example, but doing the same thing. The only difference this time is rather than going and getting the values one by one, we're just saying, okay, go and actually get all the values in one go and return them to an array, but it's going to give me exactly the same information. So again, if we look at the bottom of the screen, there's my column header, there's row 1, 2, 3, and so on. Another way of doing the same thing, if you wanted to, you could actually just go and get the row back as a single row rather than breaking it up. If you just wanted it as a single string, you can do that. So again, you can sort of see the values here as we read it. I mean, again, it's not rocket science, is it? So it's reading it in fine. But you can also, if you wanted to, just read in the entire file into a UTR array, just because, you know, sometimes that's convenient, that's what you want to do, so we can do that. So if I sort of let that fly, you can see all the things going in there. Now by default, as I said, this is going to strip off the BOM marker for us, but if we didn't want to strip the BOM marker off, if we wanted it there, then a property of this little class basically says, well, don't automatically remove the byte order marks. If I set that to false, and now I read in the file, then you can see that the BOM marker's there, and you know, I could act on that if I wanted to do anything, and so on and so forth. And in all cases, when I destroy the instance, it tidies up after itself. It closes all the channels and what have you. So yeah, I mean, it's really not that sexy, really, but hey ho. So, as I said, there's kind of very little to it. When you all the examples I've just sort of, you know, done, pretty much everything was done for us. There are quite a lot of properties that you can set, but a lot of them, as I say, almost get a set by default. For instance, the file access, am I doing a read, am I doing a write, am I doing an append? Well, the minute I say go and read a line in, or the minute I say go and do a write a line out, if I haven't set that property, it's smart enough to know what I'm trying to do anyway, so it kind of goes and sets it for you. The only time typically where you might want to set it is if you want to do an append as opposed to a write. So in that instance, if I created an instance and said, okay, set the file access mode to append, and then started doing write line, it wouldn't create a brand new file. It would just, you know, potentially sort of add on to the end of an existing one. And there's properties for the, what happened there? Properties, things like the file name. Again, if you want to tell it, you know, binary as opposed to text. I mean, these things you'd recognize from doing your direct inputs and what have you. Delete on no write's an interesting one, because the way this kind of process works is that when you kind of say go and create an object of it, I think it creates the kind of a file for you. Actually, no, it doesn't. It does it when you think to the right. There's basically there are instances where you could have created an instance, and then if you never actually wrote to it, you'd end up with a file at the end with nothing in it. But by default, it makes sure that's never the case. If you create one for writing and you never actually write to it, it'll tidy up afterwards and it'll kind of delete that file, so you don't end up with lots of sort of 0K files on your machine. We're only personally dealing with UTF-8 at the moment because that's what DataFlex is dealing with. So we tell it that it's UTF-8, but actually if you were kind of, if you wanted to put in different BOM markers, if you wanted to output something else, it supports all of those. And depending on which one you set, that would be the byte order mark that goes into the file. Oh, goodness sake, stop doing that. I must keep clicking somehow. By default, it will automatically remove the byte order mark when it reads it in, but it doesn't have to. By default, it will automatically add it when you output it, but again, it doesn't have to. You can have a header row if you want. When you're reading in files, by default, it will skip any blank rows, but again, if you don't want that, you can kind of turn that off. It will automatically get rid of any control character return line feeds and what have you, but again, if you want to preserve them, you can control it. And obviously, if you're dealing with CSV files, what's the delimiter, what's the text qualifier, so on and so forth. Beyond that, there's nothing to it. The supported methods are things that we've basically seen, things like fetch row, which will return the row as a single string, fetch row value, where you can go and get a particular column value, or fetch row values, where it'll return an array of all the values. You can get the column count, you can read a line into memory, you can read a file in one go, you can write a file out in one go. Again, sort of, you've got a utr array and you just want to go blat to file. If you're writing and you want to set the column values, you've got your row value. When you're happy and those are all set and you want to write it out, you can say write line. And there's also a clear, because when you're actually writing and you're kind of loading up that buffer, if you've got say 10 values and you set all 10 and you a write line, it may well be that the next line you actually only want to change one of the values for whatever reason. So actually you could just change that one column value and say write line again, and it would still have everything from the sort of previous line still kind of in memory, whereas you could say clear, it'll just sort of trash it and sort of empty it all there and what have you. But yeah, I mean that's all there is to say about it really. It's absolutely nothing that you can't do with the out of the box stuff, but as I said at the start, it's just really an example of how it's always a good idea, I guess, to kind of create yourself these little sort of, you know, helper tools to make your life and code a lot easier. Because I mean, all of this is just using direct output and direct input, but now we've kind of got that little sort of layer of separation by having this sort of little class. It hopefully means in the future that working with text files should not be a pain in the BOM, was my sort of pun at the end. And I think I probably only did take about 20 minutes, which is a bloody miracle. I think I deserve another beer for that. So that's I mean, that's all there is to say. With all of these things, you know, I'm happy if anybody wants the code, they can have it. If anybody wants the PowerPoint slides, they can have it. It's
Peter.
Yes.
Publish it on the forum or on DFWiki.
If I could just chop out this part of the video and put it as a present, you know, as a video. I'll put it on the Unicorn page so people can see it there. If that's okay with you, Peter.
Yeah, do it if you like. So I'll certainly can make the code available, because I mean there's literally two classes to it. There's the kind of it's a bit like a grid where you've got the kind of, you know, with the grid you've got the grid and then you've got the data source. It's a similar sort of thing really. You've got the kind of handler class, and then you've got a little separate class which is when you're reading in rows and things into memory. There's a little class for that. But I mean, it's, you know, with everything and comments and everything, it's probably only about 700 lines of code. It's nothing much.
I'll email you tomorrow about
yeah, absolutely,
how and where we put it.
Peter, may I ask a question?
You may.
Yeah. What if you decide that you want to read 4 lines and then you want to read block 2K or something? Do you have a message for that, or do I get out the channel and do it myself? Or
you can actually let me hang on. Let me see if I can find my code again. If I can work out what I'm doing. Where's my?
Well, you can get the channel and do normal stuff also.
Yeah, no, absolutely. That's what I was going to say. Why all of a sudden I've lost my. Oh, here we go. If I actually see if I can find the class, there's a load of kind of like examples in here somewhere.
Mm-hmm.
And where are they? Yeah, you can actually kind of mix and match. So you can actually create an instance, and you can actually sort of, you know, you can actually go and get the channel, and then you can kind of do whatever you like with it. So it's still, you can still use this in conjunction with all the kind of read lines and reads and everything anyway. So you would be able to do that, I would imagine.
Of course, yeah. Very nice.
The only thing at the moment is that because we only, you know, I mentioned all the kind of different BOM things that it supports. It supports them in terms of writing them out. In terms of reading in at the moment, I mean, because this is written for our application and we are saying to our clients, we are exclusively dealing with UTF-8, we'll strip off any BOM, but if it comes in and we detect that it isn't UTF-8, then tough, we're not going to try and kind of translate it at the moment. So that would kind of be next on the list, I guess, in trying to do stuff. UTF-16 would be easier, but some of the other stuff I'm not sure about. So at the moment it would strip them off, but if it did say, oh, this is UTF-1 or something, it would be, you're on your own kind of thing. But yeah, I mean, the whole code here, even with quite a lot of comments, I mean, what are we on? We start up the top there. Some of these things I've just added to make it run today. Some of these methods are methods that are in our application that wouldn't normally part of this class. If I scroll right down to the bottom, okay, it's about 900 lines of code, but there's quite a hefty chunk of examples and stuff within there as well. So there isn't a great deal to it.
Looks good.
My glass is getting empty. I'm going to need another one.